Hey y'all, it's your main math teacher, Mr. Boyd, back at it again, and today we're going to learn about inverse functions. First, we're going to do a little bit of a fraction review, but our main purpose in this video is to learn the concept of what an inverse function is. Okay, so to start with our fractions, one of the things that sometimes we struggle with is recognizing the difference between these three things. And so what I'd like you to do, don't treat this as instruction right now. I'd like you to pause the video and see that you can or cannot get these on your own first. I am going to walk through all the steps and explain them, but let's see where you're at before we go through the video. Okay, so pause now. All right, guys, to get the first one, you got to realize that you need a common denominator. That denominator is going to be 6. And the way I get that is by doing 2 times 3. I'm going to show it in a way that a lot of people in class today thought was a little bit cumbersome, or doing the most, as they say. I guess that's kind of dating the video, isn't it? But in any event, some people thought that was a lot of extra work to do. The reason I'm showing it is it'll always work. I'm just pulling this 2 over there and this 3 over there. And what that does, that guarantees that we'll have the same denominator. 3 times 2, 3 times 2. So I get a 6. And then I get 3 times 1 is 3. 2 times 2 is 4. And there's, of course, that plus in the middle. So we get 7 over 6. Okay, now what about this one? Do we need a common denominator on this one? No, not at all. We only need that when adding and subtracting. So what we're going to do on this is multiply straight across. And when you do that, you're going to get 2 over 6, which simplifies down to 1/3. Although, did any of you notice that you can actually cancel out these 2's and get 1/3 that way? Alternate method. Kind of cool. A lot of people don't notice that, but it's kind of a neat trick. And then down here, anytime you have a fraction divided by a fraction, you're going to flip that bottom one and bring it up. Now the technical term for that is you're going to multiply by the reciprocal. Hey, I don't really care if you know the term or not. You got to know how to do it though, okay? So then we get 3/4 on that one. Okay, let's formalize it just a little bit before we move on. Okay, if we're going to add or subtract fractions, what are we going to have to do first? We're going to need a common denominator. And how do we do that? We do that by multiplying by really interesting and weird forms of the number 1. Notice that's what we did in this first example. We multiplied by 3 over 3. I mean, I hope that you can verify that 3 over 3 is 1 and 2 over 2 is 1. That, by the way, is why we're allowed to do this move. You know, normally in algebra we say, hey, if you're going to do something on one side, you better do it to the other. However, when you multiply by 1, you haven't changed the value. You've just changed the way it looks. And so that's totally fine. As long as we're not altering the value, we're not in trouble. Let's try some more exciting versions of something very, very similar. Okay, let's try these. And if you're up to it, pause the video and try them on your own. I mean, we really want to have you do as much as you can, because that's when you're going to learn the most, is when you get stuck and then you see it. You kind of get that aha moment by doing that. Okay, this first one, I'm doing addition. I notice this doesn't have a denominator, so I'm going to make one. Okay, and then I know that I need a common denominator, so I'm going to bring the x over here. And then I have 1 times x is x, so we're all good there. And then what do I get? I get 1 plus 3, x times x is x squared. And the denominator is x. Boom, done. Cool. What about the next one? This is x cubed, that's x. There are 2 ways to do this. If you want to bring the x over to here, that's fine. Or a lot of people notice that you could just multiply by x squared on both sides. Because what does that do? Now you have x times x squared, that is x cubed. So now they match. Okay, 5x plus 3x cubed. And then this is where it gets kind of fun. Minus 2. You might want to put this in parentheses so you realize that you're distributing this x squared. So minus 2x squared. And then this is the one that trips people up a little bit. It's actually plus x cubed. Okay, because we have x times x squared, that's x cubed. And that's a minus. But we also have that minus. We're doing minus a negative here. So that's why it's a plus x cubed. And then divide by x cubed. Okay, now be careful. A lot of people in class this year noticed that they thought that they could simplify this more. They felt that they could divide x cubed by x cubed and cancel them out. Can't do that. That would be using division to cancel out addition. Or some people were hoping that they could use this 3x cubed and that x cubed and cancel them out. But you can't do that because this is being protected by the root. This is actually done. There's nothing more that I can do with that. Okay, what about here? This one gets kind of interesting because everything we've done so far has been an addition problem or a subtraction problem. This has all kinds of stuff going on. It's an addition problem, it's a subtraction problem, it's a division problem. So what we'll do is we'll treat the numerator like it's one question and the denominator like it's another. We'll work on those, and then we'll combine them together in the end. So here I go. I'm going to take this 2, and I know I need a common denominator, so I'm going to multiply it by 4 over 4, and that will then give it the denominator of 4. Over here, I really want this one to have a denominator of x minus 4, so they match, but if I do that, I've got to multiply on top as well. Let's simplify. Then I have 3x, 2 times 4 is 8, so minus 8 divided by 4. And then over here, let's distribute. I have 2x, and it looks like minus 8 plus 3 over x minus 4. Cool. Now, why this is important, we now have a fraction divided by a fraction. So I get to multiply by the reciprocal. So what does that look like? That looks like 3x minus 8 over 4 multiplied by x minus 4 over 2x minus 5. Okay, where did I get the 5 from? That's minus 8 plus 3. I just combine them together. And then, for good measure, let's multiply them out. So I get 3x squared. And then it looks like when I multiply these, I get minus 12x. When I multiply these, I get a minus 8x for a grand total of minus 20x. And then I have negative 8 times negative 4 looks like a plus 32. What about the denominator? That looks easier. 8x minus 20. Can we simplify it? Not really. I mean, maybe this is factorable. I'm not going to take the time to figure it out. And it looks like these are all divisible by 2 except not the 3. Okay, so it may be simplifiable. It's not obvious, and so I'm not going to worry about it for right now. Okay, what about example 4? Okay, on this one, I want a common denominator, and so I'm going to go back to that trick from the very first example where I multiply on both sides. So I'm going to put an x minus 1 on both of these, and I'm going to put an x squared on both of these. Best practice would tell us that we probably need to parenthesize these guys so we realize that we're distributing. And now we'll do it. So it looks like I get 5x minus 5. And then what happens in the middle here? I'm going to bring the x squared into there. So I get 2x squared, and it's subtracted. So minus 2x squared. And then I have an x cubed. This one is also added, minus a negative. Okay, what about the denominator? Okay, they each have the same denominator. And I'm actually going to distribute that as well. So x cubed minus x squared. This might be simplifiable. I'm not sure. I'm not too worried about it now because the purpose of the lesson right now is to make sure we are very comfortable dealing with operations on fractions. And if you can get to here, you definitely are. Okay. Now let's get on to the new learning now that we've done our review. Okay, today we need to talk about inverse functions. And I'm going to argue that you already know all about inverses, even though you may not be using the language. So like, for example, if I say x plus 5 is 10, how do you solve that? Okay, your instinct might be to just say, well, come on, we already know that's 5. That's true, of course it's 5. But that's not useful in building on an understanding. So the question really is, what is the algebra move you could make? Okay, well, you probably know to do minus 5 and minus 5. But the deeper, more important question and the connection to make here is, why is it a minus 5 that makes this successful? Like, why do we do that? And people say, well, because my teacher taught me, or because that's what works. Well, of course it's what works. Why does it work, though? So look here. You have 5 minus 5. 5 minus 5 is 0. It turns out that by virtue of the fact that those are opposites, these will cancel. And that's meaningful. The same way that if we have 2x equals 10, how would we get rid of the 2? We would divide. Have you ever thought about why? It's because this is multiplication, and multiplication and division are opposites. They cancel out. So let's make a little list here. We know that addition and subtraction are opposites. Multiplication and division are opposites. I know that if I have x to a power, the way that I get rid of a power is with a root. Okay, we have all of these opposites. Well, opposites is not the technical name. The technical name for it is inverses. Okay, these are inverse operations, or mathematical operations. But what we're dealing with today are inverse functions. So one way you could think about inverse operations is they're operations that undo one another or that cancel each other out. So what will an inverse function be? Well, that'll be functions that are able to cancel one another out. Okay, and the language I have here is that it's when one function sort of undoes another one. Okay, there is a piece of notation here that's important for you to get. It's right here. It looks like it's f to the negative 1 power. What we actually say is f inverse of x. Okay, and then we have the formal definition here. Now, I said they undo one another. So what we would know about a function f of x, a function f of x does something to an x value. Like, for example, let's say it was f of x equals x plus 2. We would know that the function says take the input and add 2 to it. So if you wanted to undo adding 2, you would do the opposite. You would just subtract 2. They would cancel out, and what would be left over? What would be left over is x. Now, in fancy language, that's what this is saying right here. It's saying, hey, if you take an x value and you run it through the inverse function and the function, or if you take an x value and run it into the function and then through the inverse function, what you'll get out is what you started with. Meaning, whatever the f function does to the x value, the inverse function will undo that so it is turned back to its original form. Okay, let's try it in an example so you can see what I mean. We have two functions here. We're being told we have the function 2x and its inverse, f inverse of x, which is x over 2. We're asked to verify, using the definition, that these are inverses of one another. Here's what it looks like. To show that f of f inverse of x is x, all we're going to do is we're going to take the f function, 2 times something, and the something is x over 2. So then these 2's cancel and we get x, which is exactly what we were told to do up here. What about f inverse of f of x? Okay, so for that one, we're going to take f inverse, which means it's something over 2. What's the something? That's the f function. So that's 2x. Divide out the 2, and we get x. All right, in this one, we get to figure out which is the inverse of our function f. Now, we can save ourselves a little bit of work. We can actually do this by inspection. So what that means is right here, I see that whatever this function is, it's saying that you take x, you add 2 to it, and divide by 4. So what's going to have to be in the inverse to undo this adding 2? Well, the inverse of adding 2, probably a minus 2. So while this one has division by 2, that's probably not right. This one has subtraction by 2, so that seems promising. What about this? This is divide by 4. So our inverse function must have multiplying by 4. Okay, so again, that looks promising. Now, a lot of people, when they're first learning, they say, hey, look, f and q look really similar. These two functions are basically the same as switch numbers. Maybe that means they're inverses. But that's not the case. So we've eliminated this one by inspection. Now we have to actually compose the functions to show that r is the inverse of f. So first, we'll do f of r. So f of r would mean we take the f function, which is something plus 2 divided by 4. What's the something? That's the r function. So 4x minus 2, the 2's cancel out, and then 4 divided by 4 cancels out, so we get x. So that worked. Then we can do r of f. And for that, now we're going to take our r function, 4 multiplied by something minus 2. What's the something? It's the f function. So now our 4's cancel, we have a 2 minus 2, and x is what's left over. So that worked. What about example number 7? We get to demonstrate that f and g are inverses of one another. Okay, so to do that, we're first going to find f of g. And what does that look like? F function with a g plugged into it. So I'm not going to write x, I'm going to use the g function instead. So I get x cubed minus 8, and then we have the plus 8. So plus 8 to the 1/3 power. All right, looks like a negative 8 and an 8 cancel out. So I get x cubed to the 1/3. We must remember what to do when we have a power to a power. We multiply them. So that would be, equals x to the 3 over 3, which would be x to the 1, which is x. So hey, that worked out. What about doing g of f? In that one, we've got something cubed minus 8. What's the something? That's x plus 8 to the 1/3. So again here we have this example where we have the 3rd power and the 1/3 power. Those cancel out. We have x plus 8 minus 8. Well, plus 8 and a minus 8 cancel out. In case it's weird, you do have to cancel them out in that order. You got to think about it that way. These are sitting right here next to each other. You can't just do the 8's across. Since those cancel out, we do get x. So we have shown that these are in fact inverses of one another. Now, what's normally going to be a test type question is, whether it's my question or an IB exam, you're going to be given a function and you'll be asked what the inverse of that function is. Now for a simple one like this, like x squared, you say, well, I know the opposite of squaring is square rooting, so there's the inverse function. But we're going to look at this in a tabular fashion so that we can make a connection that will help you remember the process to find an inverse function when it's not so easy. Here we go. Let's square these up. So we get negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, make that a real 1, sorry. 1 squared is 1, and 2 squared is 4. What about over here? Taking square roots, square root of 4 is 2, square root of 1 is 1, square root of 0 is 0, square root of 1 is 1, and square root of 4 is 2. Now, it's a little weird that I've made this 4, 1, 0, 1, 4. I have repeats in my x values, but all I did there is I wanted these to connect so that I could show you that when we do that, when we have inverse functions, these also naturally connect. Okay, we have 0 goes to 0, negative 1 to 1, negative 2 to 2. Now, in our perfect world, this would have been a negative 2 and a negative 1. That way the x and y's would have swapped perfectly. But we can't get negatives and positives out of a square root since we didn't choose it. So here's what's important that you see though. Since I picked inverse functions, the x values here, which are the inputs, are represented in the outputs of the inverse. And the outputs, the y values here, are represented in the inputs of the x function. Functionally, we switched x and y. So that leads into our process for finding inverses algebraically. Okay, and here it is. I'm not going to leave it on the screen too long, so you may need to pause it to write it down. We're going to swap x and y, solve for y algebraically, and then we're going to celebrate because that's awesome, we did it. Let's look at some examples. Let's try example 8. All right, in this one, we already know the answer. We know the inverse of 2x is x over 2. But we're going to use this as an example to show that our process worked. So here's what we're going to do. Step 1, I'll annotate it. Step 1 says to switch x and y. Wait, where's y? I don't see y. Okay, you guys, you got to remember that f of x is y. So maybe I'll write that first. Y equals 2x. And then when we say swap x and y, what we mean is anytime you see the letter y, please instead put an x. And anytime you see an x, please instead put a y. Step 2, solve for y. We're going to divide out the 2 so we get y by itself. So I get x over 2, and then I'm not actually going to write y because we were asked to find the inverse, so I'm going to use inverse notation to demonstrate that I'm done. So f inverse of x. And y'all, that's all it is. Okay, not horrible, right? Let's do another one. What about example 9? Okay, in example 9, we're going to find the inverse. So I would suggest that you pause the video and do this one on your own and then watch to get some feedback. Okay, in this one, I'm going to realize that's a y value. So when I swap x and y, I'm going to get x equals 2y cubed plus 3. So then I can subtract 3 on both sides. I can divide by 2 on both sides. And then I can take a cube root on both sides. And in this one, it's not f of x or f inverse of x. The initial function was s, so this will be s inverse of x. One more. Example 10. All right, this would be a great time to pause the video and try it on your own. Okay, here I go. We're going to switch x and y. We're going to multiply by 3. We're going to subtract 2. And then we're going to write it in inverse notation. Okay, don't worry so much about the notation on this one. If you even got down to y and got the 3x minus 2 on your own, you're in really good shape. That's going to conclude today's video. Hope you enjoyed finding inverses, and we'll see you next time.